Hello, friends. This is Gaurav from Automation Hacks, and welcome to a new series on gRPC testing. In this series, we are going to talk about what gRPC technology is, what are the different features, understand some of the core concepts, and then talk a lot about testing. We are going to take an example service, which is a root guide service taken from the gRPC Java codebase. Then we will understand how the service is actually built, understand a little bit of its code structure, and then jump into how do you approach the different layers of the test pyramid and automate it. So we'll talk about unit testing, the client, the server, writing an end-to-end test, and then also a load test on this API. So this is going to be helpful for people who are, say, new to gRPC testing in their organizations, or someone who is just curious and might want to learn for the future. So I'll take you on this learning journey with me. Super excited about it. Let's get started. So I've written a series of blogs on this topic already, and you can find it on my newsletter, newsletter.automationhacks.io. It's on Substack. Now, I have a series of blogs on this, and we are going to use it as a reference as we go through this entire series. I will present some topics from the blogs, but then mostly we are going to look at the editor and just work on the core concepts. So let's start with the first one. I think many people are familiar with REST APIs and Postman and tools like that, and a bunch of other libraries to automate these REST APIs, right? Like REST assured, requests in Python, so on and so forth. It's a pretty well understood technology, but what is gRPC? All right, so let's understand what gRPC is all about. gRPC is a modern framework useful for designing APIs, which allows a client to talk to a server as if you're talking to a local method function call. We will take a look at what this means when we dive into the code, but essentially you can think of it as just another function call in your code base, but the call actually happens over the network. Now, the core part of gRPC technology is something called as protocol buffers. And protocol buffers is an open format which allows you to specify how you want certain objects to be serialized and deserialized. It is used as an interface definition language. An interface definition language allows you to define the interface of the API. Essentially, what are the methods that this particular service will support, and what would be the request, what would be the response, and things like that. Now, all of the request and response semantics are actually defined in protocol buffers, and we'll see an example of it. But a key feature to call out is that protocol buffers allows you to generate code in any language. So once you define, say, the structure of your request and response using protos, you can use the proto compiler to compile it into a language that you might be using. So this allows for pretty interesting and sort of language agnostic way of writing services. So this diagram that I've picked from Introduction to gRPC on the site um, basically shows a server where you have a server that's written using C++. And there are a couple of clients of the service. One is written in Ruby, another can be written in Android Java. And they make a proto request, they get a proto response. Now you might be thinking that this looks similar to a JSON request and response, and you wouldn't be very far off. It's just that proto is a much more efficient and compact structure to allow very efficient communication over the network. And another key part is this thing called as stub, wherein a stub basically allows the client to talk to the server in an efficient manner. And we'll see this in code as well. Why would someone want to go for gRPC, right? There are a bunch of features. So I already talked about that. Yes, clients can call any methods within the service. It is language agnostic. We talked about that. This is an interesting bit wherein gRPC allows full duplex streaming. What it means is you can either send a single message, get a single response back from the server, or you could keep a connection where the server keeps on, sending messages afterwards as well. And there is bi-directional streaming of messages as well, wherein it's like the stream from the client and the server are open, and the messages can be read or written in any given order. gRPC supports sync and async flows. It has advanced capabilities for load balancing and failover, canceling, cascading calls in case something upstream fails, and also allows interaction at the application layer. Another feature of gRPC is that it uses static paths in the URL for performance reasons. So what it means is there isn't like path params as you see in REST APIs, but rather a constant static URL, and then any additional information is actually passed in request headers, which is called as request metadata, and in the request body. And it has also a set of errors that are more directly correlating to HTTP status codes. I've linked to a couple of videos in this blog in case you want to get a more background of gRPC and its features and things like that. Certainly found it very useful. Now, what does protocol buffer mean? Yeah, I think we already talked about, but I think this diagram will give us a better sense of what it is. So you can think of it like a certain workflow that we'll follow, wherein you'll create a proto file to define some data structure. And we'll see an example of it. Once this proto file is there, you can use the proto compiler to actually generate code in the language that you are working with. So say Java, Python, any of the other supported languages. Now you take this code and you actually compile it with your application code, right? And finally, with that, you get code in your particular language in which the service is written, and then you can keep on using protocol buffers to serialize and deserialize the data, basically convert from a text format to an object and vice versa. So now let's take a practical example to make it more concrete. So here is a person.proto class where I have a message for a person. Now this has three optional fields, right? None of them are strictly required. So I have a string name with a value. I have an integer, an int 32 of type ID, and a string of email. So if I have this proto and I compile it using the proto compiler, it will generate a long file which we can use. And the compiled classes also supports a builder. So this would be like a builder interface in Java. So you have a person John with person.new builder. Then you can use the simple builder semantics to set the ID, set the name, set the email, and things like that, and then work with it in your code base.